Hey guys, I guess this is video number 28 or something now, and I'm just going to bring you up to speed on how everything's going. What I'm doing here right now is I'm draining out everything from this capacitor. It's nothing but back EMF, and I'm just killing it off by running it through this series of resistors. It's very low ohmage, and it'll just deplete it. It gets a little warm, but then it goes away. So when that's dead, then I'm going to reconnect everything here. So don't let this crazy bowl of dog hair intimidate you. Most of this is not even connected. Just forget about it for now. All we're going to do is we really want to just test the toroid that's going on this end here, and the winding that I've got. Now this toroid is not connected to any of these wires. The toroid's only two wires are incoming and outgoing right here, so we get an AC waveform out of there and just run to this light bulb. You're not going to see this light bulb light up. I still don't have decent enough magnets in here. These are just ceramic magnets. I don't have good toroids. I have two split toroids here. They're taped together. I'm probably using all the wrong materials for it. It's only 18 gauge. Maybe it should be 16. It's not large enough. It barely has enough space to turn, but it doesn't bump anything on the inside. It does turn. You can see. In any case, it will run, and it does produce a voltage I can feel on my tongue. And the problem is I can't get it to go with this LED here, because this is a 120 volt LED for the wall, and I don't have anything that's more reasonable for proper testing here. So we won't see any output here. But the point is, the way that I have this wound, there's no drag on it because I believe it's overcome Lenz's law. That's a big statement to make, I know, but you'll kind of see what I mean. So I can't remember if this is on or not right now. It doesn't really matter, because even when I change it by changing the on and off, whichever one it is on or off right now, I don't know, because we won't see it light up. It doesn't change the speed of the wheel in any way, so there's no drag, which is really awesome. So the capacitor bank here for the back EMF collection is pretty close to dead now. So what I'll do is we're going to run initially from this power supply here, a negative and a positive, straight into this little breadboard, and it's going to feed the emitter and the collector with the negative. The base is going to be fed with an off and on signal that is supplied to it by the Hall effect sensor, this guy right here, which is running at 5 volts, which we're running through here. So we're going to take about 16 volts from here, run the transistor with it, but we're going to pull some energy off. We're going to run it through here from 16 volts, drop it down to 5 volts so that we can safely run the actual, this guy here. So this is the one that's pulsing. There's two that are pulsing, one on this side, one on the other side, and then this guy is acting as the notification, the trigger. Okay, I think we're about good here, so we can just yank this out, and I will start things from scratch after I mount this up properly. Just give me 1 sec. I don't know how to reverse this. It's taking pictures. I don't know how to reverse this camera. Hold on a sec. I gotta stop the video and then we'll splice together. Okay, we're recording again. Just going to... Yeah, it's weird. It doesn't have the ability to reverse the feed once it starts recording. Sorry about that. I did not realize. Okay, so now we're just going to do some of the hooking up, and then we're just going to push power. And you're going to see the wheel here will self-start. So this guy's, she is dead. But we just need to redirect this back EMF that's coming out of this set of coils here. So this is what's powering these coils here and here. But back EMF, we push negative into this side, positive actually flows out. We make sure that it's positive by rectifying it through this diode and then just letting it collapse into this capacitor bank. So the same thing applies for the negative. We've got a diode. They're all set up. This is basically dead, so it's not running anything. So a light will come on here. So I'm just going to turn this on, and we should see that start. Boom. Off she goes. So we get a little knocking. We are at 1 amp right now, about 11 volts, and it's speeding up. We are at about 1.2 amps, and it's still speeding up, 10 volts. The axle is spinning, the magnets inside the toroid on the other side. I'll take the camera down and bring it around so you can see it. Try to do this in one fluid shot here for you. Hold on a sec. There you can see it. Just spinning. I don't know if we have this actual light bulb turned on right now, but once she's up to, I don't know, 900 RPM or so, it might take a few moments to get there. You can see, here's our amps, 1.15 amps. It's our voltage. The voltage will climb as the speed picks up. The amperage will drop as the speed picks up, because it's taking less amps to push the door open by pushing this wheel forward. But the voltage will climb. So you can see it's spinning pretty good here. Let's do a quick test. I don't know if you can see that. About 500 RPM or so right now. And it will just continue to build. Okay. Give me a sec here. Let's put this back in place. Sorry, it's my crazy camera clamping system. Okay. Speeding up. Amperage is down to about 1 amp. Volts are back up to 13.5. The back EMF in here will be building, not super fast. Now, just so you understand, all this crazy hairy wiring is for something you didn't see, which is actually sitting over here. Actually, I can probably turn the camera and you can see it. It's for this guy, which I have not connected up to the system yet. There's still some modules that I was waiting on. But otherwise, everything is wired and ready to go. So this is the optimal configuration for what I'm sort of doing here on a breadboard. It's just garbage. But that will actually run all 3 of these Hall effect sensors simultaneously. Well, they'll be distributed in timing. There's 4 sets of magnets. It's kind of like a cross or cross section. But there's 3 sets of coils. The coils can only be set off once the magnet has approached it, which means only one set of coils can go off at a time. So I'm pulsing a pair of coils at a time. So no more than 2 coils could ever be pulsed. But I'm going to do 3 triggers, which is going to allow me to use the least amount of energy to pulse the wheel, which is about 30 pounds or about 14 kilos, as fast as possible. This is going to get to around 950 RPM if I just let it keep going, and if I turn it off, it'll keep spinning for about 20 minutes. It's got ceramic bearings, and she just goes like snot. Right now we're converting what is 15.5 volts through this DC to DC converter into 5 volts steady for this guy. The amperage is sitting at about 1 amp. And let's see what we've got inside this guy. His back EMF is Probably just building. Well, it's definitely building. I'll bring it up to you here for a sec. Okay, so we were at 2 point something or other. You can see it's building. It's to trickle. That's fine. We're not looking for over unity here in this. We're just trying to build the most efficient pulse motor that we can, which will utilize whatever energy we put into it initially for as long as possible. What we really want is we want that axle to spin as fast as possible for as long as possible, and to make the magnets that are inside the toroid spin and hopefully defeat Lenz's law, which means we should be able to get a very, very high voltage out of it. The problem right now is I don't have the right size toroid, I don't have the right size wires, I have a terrible hand wound toroid, it's the wrong kind of toroid, and I also have terribly weak magnets in it right now. So I'm ordering new magnets, and one of my patrons is, shout out to Sheldon, is ordering the better toroid, and we're going to put those things together over the next month, and we're going to see how much better we can get this thing to run. So right now, let me see what we're getting here for RPMs. This is a not such a hot tachometer. Well, all right, 850. So she's coming up. Yeah, well, it turns itself off. But about 850 RPM. Still got a little bit to go. But we just want to see if it slows itself down if I change the orientation of this fella here, of how it's plugged in. Does it get faster or slower? Does it matter? I can't remember if it's under load right now. It's not going to have enough voltage to actually go, because it's designed in the circuitry here to go off 120 volts. It might go off at 60 volts, but I don't have this toroid configured to be to help me get enough voltage out of things right now. But that's an evolution. So right now we're just looking to get AC off of there, so there's no rectifying. It's just going straight wires to wire. I can still hear it speeding up, so let's see what we're at now. $890. I don't know what that is. Like, why is that? 880? No. 850? This thing's confusing. This is weird. Hold on. I want to go back to number 1. Off you go. Number 4. Whatever. I'm not sure how many of these it contains. Number 5. Oh God. Anyway, it goes away quickly. Turn it off. Okay, never mind. I'll do one more visual test here. $915. So we'll get a number 1. 916. Okay? 916. So if this is under load right now, meaning it's trying to power this light bulb, it's kind of like a dead short. But she's spinning pretty hard, 900 RPM. So if I do this, it should either speed up or it should slow down if Lenz's law is having an effect at all on the magnets back there that are inside the toroid. If they're not, then it'll either be a higher RPM or it'll still be climbing. Let me check. Here's number 1. 935. No, forget about the others. 935. So that's higher than the 915. Now let's check it again. Number 1. Let me get that shine off. Ah, hold on. Ah. There. Still climbing. 940. So it's still going up. However, if I pull this line again and it's not currently under load, when I pull this line, it's a dead short, it's under load, it should immediately decrease. So let's see what happens. We're at 16 volts and 0.85 amps. That hasn't really gone, there's no change really there. The voltage is all the way at the top. The amperage is continuing to drop. I've seen it go as low as 600 in this case. So we're going to pull this again. I don't hear any change of speed. The magnets are going like nuts. This is still climbing. It was 153. 953, I say. So, did I overcome Lenz's law? I think so. But am I getting a lot of voltage out of it right now with the materials and the size of toroids that I'm currently using? No. So, the next thing I want to do is I want to get rid of this mess, and I want to attach everybody to that fellow over there, my circuit board. And then we'll power it from the DC power supply, because I can't do it for my capacitors right now. I'm still waiting for two more modules to go on that board to try to help make things possible. But what was that? That was 935 or something, 940. So let's change it again. Should go up or down or something. Well, it's at 961.2, 4, 5, 6, 7, 8, 9, 962.1. So it's still going up in speed. So it's a little baffling. I very well may have been able to overcome Lenz's law there. Because no matter what I do, like, I know this would be a much better example or demonstration if I was lighting something up and you could see that it was actually turned on or not. Maybe another way I could do it, well, I'd have to do it in a future video, I don't want to drag this one on, is to just attach a multimeter and just check the output, see what kind of voltage we're getting, rectify it or not. Like I don't even have it connected to a rectifier right now. It's just, you know, it's one of these guys. But I know it's definitely got some voltage going through it because I put it to my tongue. But hold on a sec. I'll just bring her back over here. You can see no monkey business. I don't know if the light's under, whoops, there we go. Under a load right now. The wiring's still there. And she's still going like crazy. But I need a better toroid. I need better windings. This is 18 gauge. I'm thinking getting 16 gauge. And I need much more powerful magnets. These are ceramic, so I don't know, the equivalent of these sorts of ceramic magnets, and they got holes drilled in them and everything. They're countersunk. They're very underpowered. The difference between this and say an N35 is probably 10 times. I don't know. But I'm gonna order some N52s. Any rate, just wanted to give you a quick update and say hello, and I'll talk to you soon.